So now we're going to deal with the quotient rule. The quotient is division. So when you have two like bases and you're dividing them, you end up doing this subtraction thing. And I'm trying to think of the easiest way to teach it. So if I have x to the fifth over x to the third, the rule is you subtract the denominator exponent from the numerator exponent. So you have to subtract the bottom from the top. So this would just end up being x squared. If you're ever in doubt, I think the easiest way to do it is to spread it out, unless you're dealing with huge numbers, right? So let's say you have z to the third divided by z squared, and you can't remember, what's the rule? Well, what we're talking about is if you spread it out, this is z times z times z over z times z, okay? So anytime you have a number divided by itself, it just equals 1. So these guys cross off, and you're left with just z. Z to the third minus z squared is just z. So this ends up being z to the first power, which is just z. You can do the same thing for when it is bigger on the bottom. So let's say I have x to the fifth divided by x to the sixth. If I subtract these two, 5 minus 6, I get x to the negative 1, which ends up being 1 over x. So what you want to do is you can do these steps, or you can take the difference, right? You don't have to, they always say subtract the bottom from the top, but really you're just subtracting the smaller one from the bigger one, and then the variable stays with whichever one is bigger. Does that make sense? So let's try another one. Let's say I have x to the fourth over x to the fifth, right? 4 minus 5 is negative 1, but 5 minus 4 is 1. So we would just stay on the bottom. So either way you write it. Let's do the official way. I'm trying not to confuse you, but I feel like it's getting worse. So this would be x to the 4 minus 5, which is x to the negative 1, which equals 1 over x. So you can do it that way, or you can say 5 minus 4, and it just is 1 on top and x to the first on the bottom. You can do it in one step, or you can think about it like that. Either way, you're taking the difference of the two, and wherever the bigger number lies is where it stays. Or you can do it that way. Let's do one that's a little more complicated, and I think it'll become easier. That doesn't really make sense, but it will. All right, so if I have x to the 5, y to the 10, z to the third, divided by x to the 7th, x to the 7th, y to the third, z to the second, okay? So look at your x's first. Which one is bigger, 5 or 7? 7. So we would just say x to the 7 minus 5 would be x squared. So the bottom would stay x squared. Y to the 10th minus y to the third, 10 is bigger, so 10 minus 3 is 7, so the y is going to stay on top. Y to the 7 stays on top. Z to the third, z squared, 3 is bigger, 3 minus 2 is 1, so the z stays on top. So that's that question simplified. Now, the fun part, if you throw in a bunch of negatives, x to the negative 2, y to the third, z to the fifth, over x to the third, y to the negative 5, z to the 2. Okay. What? Okay, negative exponent, you flip it. So let's just rewrite it with all of our negatives flipped, okay? So negative 2 becomes down here on the bottom. So the x goes to the bottom. So it's going to be x to the third, x squared, y to the third, but here's a y to the negative 5. So this has to flip. It goes up to the top. So this becomes y to the third, y to the fifth, and then z to the fifth and z squared. 5 minus 2. 5 is bigger, so it stays on top. So this becomes z to the third. This goes away. Okay? Then you still have some simplifying to do. So now I have y to the third times y to the fifth. Product rule, I just add these. So this becomes y to the eighth, z to the third, and then x third times x squared, adding x to the fifth. So this is your final answer. And you can go back, pause that, rewind it, do whatever. I'm going to leave this for one video.